In this video, we'll talk about special permissions. We'll talk about a special user called root, and we'll talk about some ways to temporarily elevate permissions when needed. Hopefully, as you're going through this, you're using a user account that you created when you installed Unix, like my Jeff account. That's a nice safety precaution not to use a privileged account like root for everyday things. But there are things you have to be a privileged user in order to do, and that's what we'll be talking about in this video. Now in Linux, the administrative user is called root, and root has permission to modify any file, delete anything, run anything. Root truly owns the system. When you need to do something that requires root permission, because there are things like a lot of administrative tasks, you could log in as root if you know the root password. That's one way to do it. But there are times maybe you just need to do one thing, or you need to do just a few simple things. And there are simpler ways to accomplish this than logging in as root. For an example, we're going to look at root's home directory. Root's home directory is in /root. And if I try to look at what's in there, I get permission denied. If we look at the permissions on the directory, we see that root is the owner, root has read, write, and execute, and nobody else has any permission on it. That's entirely appropriate for something like the administrative user's home directory. It's only visible to that user. But there is a command called sudo, S-U-D-O, and root is often also called the super user. So this mnemonic for sudo is do something as the super user. It's likely that you have permission to run sudo. There are special permissions required to be able to run this command. But if you set up your account as an administrator when you installed your Linux, you probably have this permission. If you're on a shared system, if you're on a system that's provided by somebody else, you probably don't have this permission. So that's just something to know. The sudo command runs something as the super user, which is, again, just another name for root. And the syntax is sudo, then whatever you want to run. So let's try the ls again. Now sudo is going to ask me for a password. It asks me for my password, not root's password. I give my password, and I look at root, and it turns out there's not actually anything in there, but let's confirm that. Let's do a sudo ls-a/root. There's definitely stuff in there. Now you'll notice I didn't get asked for my password again. That's pretty handy if you're going to be doing several things. By default, anything run within 15 minutes, it will stay good. So it will not ask for my password for 15 minutes. If I let it sit for more than 15 minutes, then I will get asked for my password again. The second thing to note, of course, is that our ls command did indeed work. There just wasn't anything that showed that didn't start with a dot. Now, there are other ways of getting special permissions, and those don't require you to do anything. They just happen automatically behind the scenes. And these use some extra permission bits. Now, when we've talked about permissions, you may remember we talked about the mode, and at one point I said that it was 12 bits that are stored in association with a file or a directory that define the permissions. And then we talked about 3 sets of 3 permissions. That's 9 things. So what are the other 3? We're going to talk about those now. Those 3 extra permissions, those 3 extra bits that are in the mode, are called the setuid, the setgid, and the sticky bit. Let's take a look at each one of those in turn. On a Linux system, your password is stored in encrypted form in a file. And the file it's stored in is called the shadow file. And it's in etc/shadow. And you can see root has permission to make changes to it. And members of the group shadow can read it. Nobody else can do anything with it. So only root can make changes to your password. Well, what about if you run the command to reset your password? There's a command, password, passwd, and change your password. If only root can change your password, how does that work? Well, let's take a look at the permissions on that particular file. It's in user bin. If you take a look at the permissions, see that the first set of permissions is RWS, not X. And that S is telling us that the setuid bit has been set. What is the SUID bit? What it means is when anyone runs the password command, they will take actions with the effective user ID. They will have the permissions of the owner of the file, the user, so you will have root permission while you are running that file. So that file takes your input, asks for your old password, and then it asks you twice for your new password, and then it saves a change to that shadow file, assuming that everything was successful. And the only reason it can do that is because of this guy, this setuid bit right here, because it has root permission in order to do that. I don't have to do anything with that, and there's no special permission needed by people. It's a special permission needed by that operation. So we don't have to give everyone root permission. That would be bad. In a big multi-user system, we don't want everyone to have administrator level permissions, but they do need them for tasks like setting their password. So that's what the setuid bit is for. Now, the next command we're going to talk about is a command called wall. Wall has an S in the group section. That's called the setGID bit. If that bit is set, then the effective permissions of the group are used for when that particular program is running. The wall command is a way to write to everyone's terminal session. So I can say wall, and I can say, hi, everybody, Control D to end, and I can send a broadcast message to everyone logged into the system that says, hi, everybody. Needless to say, this is something to use sparingly because this is a real easy way to be a jerk. We don't want you to be a jerk. But this program exists, and it's a way to broadcast a message to everyone that is needed, usually for administrative purposes. But the point that we're bringing this up for, that program needs permission to write to everyone's terminal session. Well, that special group TTY allows it to do that. And the setGID allows when we run the command wall, we have the permissions of that TTY group. So we have the permission with the wall program to write to everyone's terminal session. The final bit that we want to talk about is the sticky bit. The sticky bit is kind of interesting. For executables, it really has no purpose on Linux. It will come back to it when we talk about directories. We have these bits, and we've talked about their application to programs. Let's talk briefly about how they apply to directories. Really only the setGID and the sticky bits do anything with directories. The setuid doesn't really have any meaning for a directory. But with the setGID, when a directory is setGID, all new files created in the directory will have the same group assignment as the directory. So this is really handy if you have a group that's collaborating on files and you make a directory and you want to make sure that everything in that directory is accessible by the group. You make the directory setGID. Now, finally, the sticky bit. We talked about it. For executables, it had to do with whether things remained in memory or not for executables, and that feature is just not used on Linux. But it does have a very important use when applied to directory, and it has nothing to do with things remaining in memory or anything like that. You may remember when we talked about directory permissions, you have the ability to delete a file as long as you have write permission in that directory. It doesn't matter who owns that file. It doesn't matter whether you have any permissions on that file. You can delete a file. That's fine if it's my directory, but what about the temp directory? There's a directory called /tmp for temp, and it is a directory that is shared by everybody, and it's for temporary files. You can see the permissions here. They are read, write, and execute for everybody. The execute bit has this little T that tells us that this sticky bit is set. And what the sticky bit means for a directory is there's a little extra permission. Anyone can add files to the directory. The write permission applies. But only the owner of a file can delete files. That's what the sticky bit means. So the sticky bit tightens up those permissions just a little bit for things like a shared directory and prevents you from being able to delete other people's files, which for obvious reasons would be a bad thing. So there's our extra permission bits, setuid, setGID, and the sticky bit.